Okay, so this is a quick recap of the fundamental counting principle, which is an easy concept to grasp because it's really just looking at the number of total outcomes or the sample space that you could get in a problem. So to review, like I said, it's used to find the number of possible outcomes or the sample space in a situation. So here's an example. You're building a car to race in Sugar Rush. You have 4 choices for cookie wheels. You can have strawberry, blueberry, chocolate, or lemon frosting paint, and then you can have licorice, sprinkles, or M&M accents. How many different cars can you make? Well, we need to have blanks for each type of possibility, each option type that we could have. So we have wheels, we have paint, and we have an accent to the car. So we have 4 choices. 4 wheels. We have 1, 2, 3, 4 choices for paint, and then 1, 2, 3 choices for accents. And what we do is just multiply those together. Well, 4 times 4 is 16, and 16 times 3 is 48. So that means we got 48 options for cars here. Different cars that we could make. Now, that's the math way to do it. If you wanted to, and you do not have to do this, you could draw a tree, and this was explained in the other video. So here is you, and you have 1, 2, 3, 4 options for that first branch there, and that's your wheel option. And then each one of those wheels could have 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 options for paint. Okay, so each one of these little nodes down here would be the cars that we've created so far with each wheel option and then in each different paint color. Finally, and I'm not going to do this, but you would take each one of those nodes and split it out into 3 for your accents. And then you would count all of those options there at the bottom that you come up with, all of these here, after you've split each one of those into 3, and you should get 48. So that's a visual way of representing what's going on. And again, you're not going to be required to do that. The math way here is way easier. You're just multiplying numbers together. Okay? So something to think about with this fundamental counting principle. This next problem here, I want you to think about it and decide whether it is a fundamental counting principle problem. It says non-customized license plates are a combination of 6 letters and numbers. All the numbers and letters can be repeated. How many license plates can be created? Okay. So take a minute, pause the video, think about it if you want. Decide whether you think it is or isn't. Maybe try to come up with the answer. And then I'll come back and I'll give you the answer. Okay, so hopefully you paused it and thought about it. The answer to the question is yes, this is a fundamental counting principle problem. It's just presented differently. Now, like the last one with the car, okay, I'm going to draw a blank for all of my options here. So there are 6 letters and number spots that we could put on a license plate. Okay. So, like if I do the visual way, here's that. Okay, and I'm going to have 6 sets of branches coming out. Well, that first spot here, I need to figure out how many possibilities there are for that first spot. It says that I can use numbers and letters. Well, I know there are 26 letters. Numbers, it's going to be 0 through 9, and that is actually 10. 0 through 9, including 0, you have 10 options there. So really for that first spot, I have 36 options. Now, it says that they can be repeated. Okay, so that means in the next spot here, I again have 36 options. If I'm going over here to my tree, this little branch for my license plate could be branched out 36 times. That's very sloppy. Okay, and then each one of these would be branched out 36 times. Each one of these would branch out 36 times. So really what we get here is each one of these blanks has a 36 in it, because each one of those has an option. Okay, the same number of options, letters and numbers for it. That's what makes it a fundamental counting principle problem. Now, it's not presented like finding outfits or making a sandwich or making a car where you have different numbers in each place because each option is something different. For a license plate, they're all the same thing. Okay, you have 36 each time because each spot is going to be a number or a letter, and they can be repeated. So really the answer here, you could put it in your calculator, but I would say 36 to the 6th is just as acceptable, because you have 6 36s there, and you're multiplying them all together. This is a great case where drawing this tree would not be a good idea, because that's going to be a messy tree. Okay, so yes, this is a good fundamental counting principle problem, just presented in a slightly different way. Other things that might look like this. License plates are pretty common, but passwords are another thing, another option that you could do. And when you get into passwords, then you have capitalization that becomes an issue. That's something you have to consider, because capital letters are different than lowercase. You have different symbols that you could add in there. So all of that becomes another level to your problem if you present it that way. Okay, something else to think about here. I want you to think about how these two problems are different. So the first one, option 1, you're going out to eat and there is a special on a 3-course dinner. You have options of 6 appetizers, 7 main dishes, and 4 desserts. How many different 3-course dinners can you have? Okay. Question 2. You are going out to eat and there is a special on a 3-course dinner. It's starting out the exact same way. You have options for 6 appetizers, 7 main dishes, and 4 desserts. How many different food options are there for you to choose from? Okay, so the difference happens in our question here. Okay, they're both how many, they're both going to be number answers, but question 1 says how many different 3-course dinners can you have? So this is looking at the combination of an appetizer, a main dish, and a dessert, putting them all together. Question 2, how many different food options are there for you to choose from? Okay, well that is just, I have 6 options for an appetizer, 7 for a main dish, 4, and I would just add these together. So really, question 2, the answer is 17. I have 17 different choices of things to eat at the restaurant. Not combinations of how to eat them and put them all together for a meal, just 17 different things that I could eat. Question 1 here, this is a fundamental counting principle problem. So I would have a 6, a 7, and a 4. Very similar setup to number 2, but instead of multiplying, I'm going to add them. Instead of adding on question, like I did on question 2, I'm going to multiply them here on question 1. And 7 times 6 times 4 is 168. Okay, so it's really important that you read the question, because these two start out, the first 2 sentences, very similar, but that last question changes what we're looking for, and that's important to notice. So a little bit of recap here. What I just said, you got to make sure you're reading these closely. Some questions might look like they are a fundamental counting principle problem, and they are. That's a license plate problem or a password problem. But when you're reading closely, you have some questions that may look like a fundamental counting principle problem, but aren't. I think I said this wrong. Question ones that may not appear to look like a fundamental counting principle, but are. Some questions that look like fundamental counting principle, but aren't. Okay? That was the last one we did here, dinners versus options. So, whole point in me telling you this is that you've got to read the question. Don't just assume by reading the first part, the information piece, that you're going to know what kind of problem it is. Make sure that you read that question, what it's actually looking for, really close. Okay, good luck on your homework.